Good morning Year 8 and welcome to your final data representation lesson. Today's title is Understand what is meant by hexadecimal, and for this lesson you will need a pen, pencil, ruler and a piece of paper. I'll now give you 2 minutes to get your title down. Okay, so just a little recap from last lesson please. What I want you to do is convert them two binary numbers into denary numbers or decimal numbers. You will need to draw the little table out. I'll give you a minute to do that. Right, for them two numbers, the first one you should have had was 54 and the second one you should have had was 37. So give yourself a tick please if you've got them right, and if you didn't get them right then just correct it please. Today's keywords are base 16, hexadecimal, bit, byte and nibble. You should recognise the last three because they are all units of data. If you can put them in your margin please. So what is it? Hexadecimal is a base 16 system used to simplify how binary is represented. A hex digit can be any of the following 16 digits. So you've got 0 through to 9 and then A through to F. Now the reason we're talking about base 16 is because if you count all them digits, so 0 to 9 and A to F, there is 16 in total. Each hex digit reflects a 4-bit binary sequence. This means an 8-bit binary number can be written using only two different hex digits, one hex digit for each nibble or group of 4 bits. It is much easier to write numbers as hex than to write them as binary numbers. So I'll give you 4 minutes to get that copied down there. Why is it used? Hex codes are used in many areas of computing to simplify binary codes. It's important to note that computers do not use hexadecimal. It is used by humans to shorten binary to a more easily understandable form. Hexadecimal is translated into binary for computer use. Some examples of where hex is used is color references, assembly language programs, and error messages. So the key point is that computers don't use hexadecimal. Hexadecimal is simply for humans. The reason being is it's much easier to remember. So again, I'll give you 4 minutes to get that copied down. So we've got values in different bases now. So you can see on the left hand side we've got denary, which is the number system that we use. You can see binaries in the middle there, okay, base 2, and hexadecimal on the right there, base 16. So what I want you to do is, you don't need to draw the table out just yet. I want you just to write down what you think are the missing values behind the different coloured circles, and I'll give you 3 minutes to do that. So this is what you should have had. I'll just take them all off. So for the yellow, 0, 8 and 13. For the pink, 0, 1, 0, 0, 1, 0, 1, 1 and 1, 1, 1, 1. Now just to quickly go over this, we use the last 4 digits of the binary number chart. So this would be an 8 and then a 4 and then a 2 and then a 1. So what that states is 0 under 8, 1 under 4, 0 under 2 and 0 under 1. Okay, so this number there would be a 4. Now this would be an 8, add a nothing, add 2, add 1, which is going to get you to 11, and then you would have 8, add 4, add 2, add 1, which will get you to 15. And then finally for the green, okay, 5, A and D. A little mistake there, but that should be a number 5. And the reason it is A is because it can't be 10, because 10 is already being represented, okay, because it's a 0 and a 1 at the very top. So we've got to use different values, and that's where the letters come into play. Now remember base 16, because there is 16 values in total, going from 0 to 9 and then A to F. What I would like you to do, please, very quickly, 3 minutes, is get this table copied down. You don't have to draw the lines for it, okay? Just leave clear lines in between. Off you go. 3 minutes. Right, let's try and work out some examples now. So what I want you to do is copy this example down as I'm going through it with you. Again, to save a little bit of time, you don't have to draw the lines, you just need to keep it nice and neat and space things out. So the denary number is 21. Then what you have to do is you convert the number into binary. So 0, 0, 0, 1 under the 16, nothing under the 8, 1 under the 4, so do this in your head, 16 add 4 is 20, and then nothing under the 2, and 1 under the 1, so 20 add 1 is 21. Nice and easy for the third step, you split the number in half, so you literally get that 8-bit binary number, and you just imagine a line right down the middle of it. And then answer in hexes, you need to find this on the table you've just drawn, so look on the middle column, find 0, 0, 0, 1, and then go to the right side that you need to go to. Okay, so look at the hex because that's on the right hand side, and that'll represent 1, and 0, 1, 0, 1 will represent the number 5. So I'll just give you 30 seconds to finish off that there. Now, there is 8 questions there. I don't think you're going to have time to do all 8, so what I'm going to say is, can you do number 1, 2 and 3 please? By all means, if you get them done very quickly, then you move on to 4, 5, 6, 7 and 8. Now you don't have to show you're working out by doing the table every time. What I'd maybe do is just write step 1, step 2, step 3, step 4, and then obviously you'll get your answer on step 4. So off you go, I'll give you 3 minutes there. Your answers that you should have had are 1922 2E 3743 6, F, C1 and F5. Okay, now moving on to the second set of questions we need to do. So we're looking at hexadenary here. And again, you write this down just as I'm going through. Okay, so hex value equals 4a. Now what you can do, you can just write number 1 or step 1. Second step, you take the first value and you multiply by 16. Now remember what I've been saying, the reason it's 16 because you go from 0 to 9 and then 8 to F. And if you add all them up, there is 16 values in total. So that's why we multiply by 16. You add the second value. Now the second value in this case is A. Now A is equivalent to 10 if you look at the big table that you've done before on your piece of paper. So 64 add A equals 74 and that's your answer. So I'll just give you 30 seconds to finish off this example. And again, there's some questions for you to work out. So what I want you to do is do number 1 to 3. And then, just like last time, if you get finished, then you can go on to 4, 5, 6, 7, and 8. Off you go. So your answers that you should have had are 75, 102, 138, 157, 170, 188, 217 and 255. So please tick or cross depending if you got it right or wrong. Right, and to finish off, some exam questions as we always do. So just write exam questions and underline it please. And then you've got question 1 and 2, they are both conversion. So convert the hex value 2a into a denary number, and then convert the hex value AC into a denary number. And then number 3, explain why hexadecimal values may be used in an alarm system over binary numbers. So think about what I was saying about hex before and why you would use it over binary. Now for question 1 and 2, you've got to show your working, so that's going to get you both marks. And for question 3, it's an explain, so give an answer and then say why. And that'll get you your 2 marks. Off you go. And your answers are, for question 1, you would have 2a, 2 multiplied by 16 equals 32, add 10, so you got 42. For the second one, you will have 172. And then for number 3, hexadecimal may be used in an alarm system over binary numbers because it is straightforward to convert and shorter, therefore easier to remember. Okay, so point and then say why that's a good thing. And that's the end of the lesson for today. Thank you for that year 8, and I hope to see you very soon.